Hello everyone, welcome back to our channel. So, up till now we have calculated or estimated the main effects of A and main effect of B. Now we need to calculate the interaction effect of A. The interaction effect of AB, the formula is the average difference between the effect of A with high level of B and effect of A with low level of B. This is the formula. And we also know the effect of A with high level of B and the effect of A with low level of B that we have already calculated before, which is nothing but this is the effect of A the simple event of A with B of high level, the effect of A with high level of B, which is nothing but AB minus B. So simply the average difference with high level of B and low level of B. So 1 by 2 AB minus B AB minus B minus A minus 1. This is the effect of A with low level of B. AB minus B minus A minus 1. Right? So we have 1 by 2 AB minus B minus A, minus into minus plus, so plus 1. And 1 by 2, this can be written as A minus 1 and B minus 1. A into B, AB, A into minus 1, minus A, minus 1 into B, minus 1 into minus 1, plus 1. And this is the interaction effect of AB. And if you not able to calculate, just remember, if the main effect of A, here we are calculating for A ki calculate చేస్తున్నాం కాబట్టి A కి మాత్రమే మైనస్ వస్తుంది, మిగతా టర్మ్స్ అన్ని ప్లస్ అవుతాయి. అండ్ మెయిన్ ఎఫెక్ట్ ఆఫ్ B, Bకి క్యాలిక్యులేట్ చేస్తున్నాం కాబట్టి B టర్మ్కి మైనస్ వస్తుంది, మిగతా అన్ని టర్మ్స్ A అయిపోతాయి. లైక్ దిస్. ఇంటరాక్షన్ ఎఫెక్ట్లో ఏమవుతుందంటే A, B రెండు తీసుకుంటాం. ఇక్కడ Aకి తీసుకున్నప్పుడు A మైనస్ 1 వచ్చింది, Bకి తీసుకున్నప్పుడు మిగతా టర్మ్స్ అన్ని ప్లస్ అయిపోయి ఓన్లీ Bకి మాత్రమే మైనస్ వచ్చింది. సో ఏబికి తీసుకున్నప్పుడు ఏమవుతుందంటే A, B రెండు ఉన్నాయి కాబట్టి రెండు కూడా మైనసే వస్తాయి. And now let us learn about the terms orthogonal contrast and contrast. In order to know what is orthogonal contrast, first we need to learn what is a contrast. Here in the first definition of factorial experiments, we consider the three treatments, right? Three treatments. Let us say, for example, let us consider n treatments. Therefore, n treatments. The linear combination of these treatments will be in the form C1T1 plus C2T2 plus so on CnTn. The linear combination will be like this, right? We multiply with the scalars. The C1, C2, Cn are nothing but the scalars or constants or coefficients. We call it as coefficients. Therefore, this can also be written as summation I is equals to 1 to n CITI. This CITI is said to be contrast if all the constants summation I is equals to 1 to n Ci is equals to 0. If all the constants, all the scalars, if that sum is equals to 0, which is nothing but C1 plus C2 plus so on Cn is equals to 0, then we can say the linear combination of these treatments is said to be contrast. Okay. And now let us take another set of treatments. Okay. Let us take the another constants or another set of treatments. Let us say that is summation I. Their linear combination will be like this. I is equals to 1 to n Si Ti. Their linear combination. Okay. And this is said to, these linear combination of treatment is said to be contrast if summation I is equals to 1 to n Si is equals to 0. If their constants is equals to 0, which is nothing but S1 plus S2 plus S3 plus so on Sn is equals to 0. వాటి యొక్క కోఎఫిషియన్స్ కానీ లేదంటే వాటి యొక్క కాన్స్టెంట్స్ కానీ 0 అయినప్పుడు ఆ లీనియర్ కాంబినేషన్ యొక్క ట్రీట్మెంట్స్ని కాంట్రాస్ట్ అని అంటాం, లేదంటే ఆ ట్రీట్మెంట్ ఎఫెక్ట్ని ఆర్ ట్రీట్మెంట్ మీన్స్ని కాంట్రాస్ట్ అని అంటాం. Now let us learn what is orthogonal contrast. Orthogonal contrast is nothing but if summation I is equals to 1 to n CITI, we have the linear combination of treatments and the another linear combination of treatments will be I is equals to 1 to n SITI. Then these are said to be orthogonal contrast if summation I is equals to 1 times to n CISI is equals to 0. ఈ రెండు ట్రీట్మెంట్స్ యొక్క కోఎఫిషియన్స్ సమ్ చేసినప్పుడు అవి కనుక 0 అయితే then this is called as orthogonal contrast. అంటే ఏంటి, C1 S1 ప్లస్ C2 S2 plus so on Cn Sn is equals to 0, then we call the linear combination of the treatments or treatment effects or treatment means said to be orthogonal contrast. ఇప్పుడు ఈ టర్మ్స్ ఏంటో తెలుసుకున్నాం కదా, మనకు ట్రీట్మెంట్స్ ఉన్నాయి కదా, we have the 4 combination of treatments, right? So let us check whether they are contrast or not. If it is a contrast, first orthogonal contrast కావాలి అంటే 2 contrast అవ్వాలి, which is nothing but I have forgot to say this point. First, in order to be a first orthogonal contrast అవ్వాలి అంటే అది contrast అయ్యి ఉండాలి, which is nothing but the linear combination of this treatment should be constant, which is nothing but summation Ci is equals to 0, and the another linear combination, this one summation Si should be equals to 0. ఇవి కాంట్రాస్ట్ అయిన తర్వాత if their summation of this constant, if it is equals to 0, then we call it as orthogonal contrast. మనకి ఇప్పుడు 4 కాంబినేషన్స్ ఉన్నాయి కదా, మనం ట్రీట్మెంట్స్ ఏం కనుక్కున్నాం, మెయిన్ ఎఫెక్ట్ ఆఫ్ A అండ్ మెయిన్ ఎఫెక్ట్ ఆఫ్ B and interaction effect of AB. Now let us check whether they are orthogonal or whether they are contrast or orthogonal contrast. So now let us check the main effect of A. మనకి మెయిన్ ఎఫెక్ట్ ఆఫ్ A ఏమొచ్చింది, 1/2 AB minus B plus A minus 1. This is what we got, the main effect of A. And మనం దీని యొక్క కాంబినేషన్ చూసుకుంటే which is nothing but summation CITI. ఇవన్నీ ట్రీట్మెంట్స్ కదా, ఇదొక ట్రీట్మెంట్. Let us consider this is T1, this is T2, this is T3 and this is T4. ఇవి 4 ట్రీట్మెంట్ కాంబినేషన్స్ అనుకున్నాం కదా, and summation CITI. which is nothing but 1 by 2 into AB minus 1 by 2 into B plus 1 by 2 into A minus 1 by 2 into 1. Right? We are consider the linear combination of the main effect of A. So మనం orthogonal contrast అని ఎప్పుడు అంటాము? This is said to be contrast if summation Ci constants or coefficients is equals to 0. అంటే మనం ఏం చెక్ చేయాలి? వాటి యొక్క కోఎఫిషియన్స్ అనేటివి 0 అవుతున్నాయా, సమ్మేషన్ అంటే వాటిని యాడ్ చేస్తే 0 అవుతున్నాయా లేదా అనేది చెక్ చేయాలి. రైట్? సో Ci అంటే దిస్ ఇస్ C1 T1, this is C2 T2, this is C3 T3, this is C4 T4. So now let us C1 plus C2 plus C3 plus C4 should be equals to 0. Now let us consider C1 enta plus 1 by 2. 1 by 2 plus C2. C2 is minus 1 by 2. Minus 1 by 2. This is not plus, this is minus. C3. C3 is plus 1 by 2. And C4 is minus 1 by 2. This is plus 1 by 2, this is minus 1 by 2. So cancel. Plus 1 by 2 minus 1 by 2. So therefore 0. So here the constant or coefficient is equals to 0. Then we can call as main effect of A is a contrast. Main effect of A is contrast. And we will write it as contrast ante coefficient 0 అయిపోతుంది కదా. So main effect of A అనేది this one, and the contrast can be considered as A bar or A cap. A cap లాగా A bar అన్న రాయొచ్చు. వాటి యొక్క కోఎఫిషియన్స్ అనేటివి 0 అయిపోతుంది కాబట్టి 1/2 అనే టర్మ్ ఉంటుంది, which can be written as A minus 1 B plus 1, contrast of A. Okay, and now we have proved the main effect of A is contrast. Now we have to prove whether the main effect of B is contrast or not. So let us take main effect of B. Simply ఇక్కడ మనం ఏకి చేస్తున్నాం కాబట్టి ప్లస్ ఏ వచ్చింది, మనం బీకి చేస్తున్నాం కాబట్టి బీకి అనేది ప్లస్ వస్తుంది, ఏకి అనేది మైనస్ వస్తుంది, అంతే తేడా. విచ్ ఇస్ ఏబి ప్లస్ బి minus A minus 1. So now this is T1. So now let us take this is T2, this is T3, and this is T4, and multiply with the constant. 1 by 2 AB plus 1 by 2 B minus 1 by 2 A minus 1 by 2 1. So here we get this is C1, this is C2, this is C3, and this is C4. Now check C1 plus C2 plus C3 plus C4 whether they are 0 or not. So C1 is minus 1 by 2, C2 is plus 1 by 2, and C3 is 1 by 2, and C4 is minus 1 by 2. So plus 1 by 2 minus 1 by 2 cancel, plus 1 by 2 minus 1 by 2 cancel, which is equals to 0. We got summation Ci, or let us say let it be put it as S. So we will not confuse here and here. Okay. So Si, which is equals to 0 we got. So we can say that the main effect of B is also a contrast. So contrast can be represented as main effect of B is contrast B hat, which is equals to, so the coefficients will be 0. So ఈ coefficient అనేది ఉండదు కాంట్రాస్ట్ రాసేటప్పుడు. So we only remain with A plus 1 B minus 1. Right? And now let us check whether the AB is a contrast or not. Interaction effect of AB is contrast or not. Okay. Here we got 1 by 2, which is nothing but this is nothing but this statement, right? So we got this is this same, and this is a contrast. So AB is also a contrast. So AB is also a contrast. So which can be represented as AB cap, which is equals to A minus 1, B minus 1. Here simply there is a change. Here the difference. Here there is no difference. Also I can do here, which we get 1 by 2, 1 by 2, AB minus B minus A plus 1. So which is equals to 1 by 2 into AB minus 1 by 2B minus 1 by 2A plus 1 by 2 1. Here plus 1 by 2 minus 1 by 2. So cancel. Minus 1 by 2 plus 1 by 2. So cancel. Here the constants are 0. So we can say AB, the interaction effect, is also a contrast. Okay. This term will be removed. We only get A minus 1 and B minus 1. So now we need to check whether the A, B and AB are orthogonal contrast or not. When we will say the orthogonal contrast, first the A and B should be contrast. Already we proved that A, B and AB contrast. In order to be orthogonal contrast, the first condition is satisfied. Now the second condition is summation SI CI should be equals to 0, which is nothing but the sum of the constants of mean effect of A and mean effect of B should be equals to 0. So now let us, here we already done, which is nothing but S1 T1 plus S2 T2. We have only the 4 combination treatments. So S3 T3 plus S4 T4. And here S1 is minus 1 by 2 and T1. Sorry, here it is not T1, here C1. Here it is C1. C1 is 1 by 2. So 1 by 2 plus S2. S2 is 1 by 2 and C2. C2 is minus 1 by 2 and plus S3. S3 is 1 by 2 and C3. C3 is 1 by 2 plus S4. S4 is minus 1 by 2 and C4. C4 is minus 1 by 2. So if you see here, minus 1 by 4, minus 1 by 4, plus 1 by 4, minus into minus plus 1 by 4. Minus 1 by 4 plus 1 by 4 cancel. Minus 1 by 4 plus 1 by 4 cancel. So we got this term is equals to 0. So we can say that A, B and AB are mutually orthogonal contrast. So in the next video we are going to see how we are going to fit the model.